All right. Welcome once again to the lesson today. My name is Michael. We have a topic here, and it's on mathematical induction, and I want to us to follow the process and understand how mathematical induction is actually, or mathematical problems that has to do with mathematical induction are actually solved. Now, in mathematical induction, we look at series of numbers that follows a pattern, and this is a pattern we have here. There are three steps, but the main idea is that the left hand side of this equation, we have an equality sign here. An equality sign breaks down an equation into left hand and right hand side. So the left hand side of this equation must be equals to the right hand side. Now, the first step will be for us to test. We're going to carry out a test step that says that n equals to 1. All right, so meaning that wherever we find n, we're going to replace it with 1. But then the n here, first step number 1, means the first term in this series, and obviously the first term here is what? Is 1. So if you impute 1 here, it's still going to give you 1. But we want to test if 1 will be equals to everything we have here. So we have n brackets n plus 1 all over 2. So if I kind of plug in my 1 there, to be 1 brackets 1 plus 1 all over 2, which is equals to 1 plus 1 is 2. 2 times 1 is 2. 2 all over 2 is equals to 1. That means this first step statement is actually true. The next thing we're going to do will be for us to assume step 2. We're going to assume that n equals to k. This assumption is made because we want to give consideration to terms that are greater than the first term. It could be the 30th term, the 40th term, the 50th term. We want to assume that if we plug in k into that into this formula, it would actually give us exactly, you understand, just the way we got, just what we got here. We got the first term. We want to assume that if we plug in k, it's going to give us what we expected, meaning it's going to give us the same thing, or it's going to be exactly the same value with the term we're making reference to. So if we're saying the 40th term, and if the 40th term is 100, we're assuming that k is going to be equals to 100. When we plug in k, will give us what? 100. So let's go ahead and do that. We're assuming now, in that case, we're going to have everything on that series dash 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 plus n, meaning we are writing everything here. So I don't want to, okay, let me just leave it this way. Then we have n plus 1 all over 2. So in place of my n, I'm going to replace it with k. 1 plus 2 plus dash 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 plus k equals to k bracket k plus 1 all over 2. So this is my step 2. My step 2 is going to stop here. From here, I'm going to go to the third step, which is step 3. Step 3 is for me to prove. I'm going to prove that n equals to k plus 1. We're adding a plus 1 here so that we can have an automated system. If I stop at k, it's just going to make reference to that particular number. But plus 1 means I am giving consideration to not just k, but to the next term as well. And it's simply saying, okay, what if I consider the next term after k? And then after the next k, I consider the next term, I consider the next term, so I keep going. I'm giving consideration to the entire series to infinity. So that is why I'm adding plus 1. So wherever I find my n, I'm going to plug in my k plus 1. So let me go ahead and do that again. But then the first thing I'm going to do would be for me to write out everything in this step 2. 1, because step 3 is dependent on step 2. So plus 2 plus dash 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 plus k. So this is my step 2. Since I'm done with this, I'm going to do the next step, which is adding this plus k plus 1, because I'm adding k plus 1 in place of n. This will be equals to anywhere I find my n, I'm going to introduce k plus 1. That will be k plus 1 times k plus 1 plus 1 all over 2. The next thing I want you to pay attention to is this. If you look at this, sorry, yes, this series here. This series is the same thing as what we have here. It's just the same thing as what we have here. Please, let me just go ahead and simplify this. K times K is going to give us K squared. Then K times this is going to give us plus K all over 2. So this series here is the same thing as what we have here. So I'm going to bring in this here. Instead of writing this long series, I'm just going to replace it with this. That means we're going to be having K squared plus K all over 2. Then plus, the next thing will be plus what? K plus 1 equals to everything I have there. Everything I have there will be K plus 1 bracket K plus, instead of, I'm going to add this 2 all over 2. Let me put this in parentheses because this is to multiply this. Now, I'm going to write this. This is just having one denominator. So I can still be right to write this as K squared plus K all over 2 plus. Now I'm going to do something here. I'm going to write this as K plus 1 all over 2. The reason why I did this is because normally K plus 1 divided by 1 is going to give you K plus 1. Now, it's still the same thing here. These two things are the same thing because 2 divided by 2 is going to give you what? 1. So it's just the same thing. Now, this will be equals to, let me just expand this. K times K is going to give me K squared. K times 2 is going to give me 2K plus, 2K plus K plus 2 all over 2. That's what we have here. So over here, since we have the denominator is just the same, so we can just simplify it. All right, bring down your K squared plus K. 2 times K is going to give you 2K plus 2 times 1 is going to give you 2 equals to K squared plus 2K plus K is going to give you 3K plus 2 all over 2. The idea, don't forget, the idea is that we want to make sure that the left-hand side of this equation is the same as the right-hand side of the equation. So now let's simplify this. Let's see if what we have here will be equals to what we have there. So we're going to have K squared plus 3K, that's K plus 2K is 3K plus 2 all over 2 equals to, bring down everything we have here, K squared plus 3K plus 2 all over 2. So obviously you can see that what we have at the left hand side is exactly what we have at the right hand side. Therefore, we can say this mathematical statement is true. It's true. What that simply means is that, all right, if you're plugging in your K plus 1 into the series, it's going to give you exactly, you can be able, it will help you, you'll be able to calculate the number of term, any term, 100 term, 150 term, 1000 times. This formula works for that. So that's the essence of mathematical induction. And I hope you learned something today. So for more educative contents and videos and lessons like this, I want you to hit the like button, follow our page for more. And if you have any question, just drop them down there in the comment section. Thank you very much. My name is Michael. See you in the next lesson. Thank you.